this lesson, we're going to analyze the percent by mass of a compound and use that to determine the empirical formula. When starting with the mass percent of elements in a compound, there are 4 steps to determine the empirical formula. First, we are going to assume a 100-gram sample and convert the percentages to mass. We could choose any mass we want, but choosing 100 grams makes it easier since a percent is based on 100. Next, we'll convert the mass of an element to moles of that element. We'll divide by the smallest number of moles, and finally determine the subscripts for the empirical formula. Let's look at an example. Phenol, a general disinfectant, has the composition 76.57% carbon, 6.43% hydrogen, and 17% oxygen by mass. Determine its empirical formula. First, we are going to assume 100 grams and convert the percentages to masses. So for carbon, we have 76.57 grams of carbon, 6.34 grams of hydrogen, and 17 grams of oxygen. Because we assumed 100%, we can convert the percentages directly to masses. If we had assumed a different amount, we would have had to do a calculation in order to determine the mass. Next, we're going to convert each mass to moles using the molar mass of that element. For carbon, that's 12.01 grams per mole, which gives us 6.376 moles. 1.008 grams per mole for hydrogen, and we get 6.29 moles. 16.00 grams per mole for oxygen, which gives us 1.063 moles of oxygen. Next, we are going to divide by the lowest number. So we divide each of them by 1.063 moles, and we get 5.998, 5.92, and 1. We can then round these numbers to the nearest whole numbers, and we get C6H6O. We can't always round, and we'll look at another example where we can't use rounding and talk about how we identify when we can and cannot round. Diethylene glycol, used as an antifreeze, has the composition 45.27% carbon, 9.50% hydrogen, and 45.23% oxygen by mass. If we assume a 100-gram sample, what is the mass of carbon? We get 45.27% carbon, therefore we have 45.27 grams of carbon because we assumed a 100-gram sample. We can do the same thing for hydrogen, and we get 9.50 grams of hydrogen and 45.23 grams of oxygen. Continuing with the same problem, if we assume 100-gram sample, how many moles of carbon do we have? We're going to use the molar mass of carbon to convert from grams to moles, and we get 3.769 moles of carbon. We can do the same thing for hydrogen with its molar mass and get 9.42 moles of hydrogen and 16 grams per mole for oxygen to get 2.82 moles of oxygen. Given the moles of carbon, hydrogen, and oxygen, what value should we divide by? 2.82 is the lowest number, so we're going to divide each of the moles by 2.82. We get 1.34, 3.34, and 1. In order to get to the formula of compound, we're going to have to multiply these because they're too far to be rounded to the nearest whole number. We multiply to get whole numbers. If you find that you're multiplying by something greater than 2, 3, 4, or 5, then chances are you don't need to multiply and you can round. In this case, because we have 1.34, if we multiply that by 3, and we multiply 3.34 by 3, we can get to a whole number. What we do to one element, we must do to all 3. We're going to multiply all of these by 3, and we get 4 moles of carbon, 10 moles of hydrogen, and 3 moles of oxygen, which gives us the formula C4H10O3. So that is the empirical formula for diethylene glycol.